Hello?
Ooh,
Hello.
Hello.
all right.
God, Alex is here.
Yeah, who's that guy?
Jesus.
Probably have collected some of the stuff from earlier, so it's a little easier to grab. But
Guys, I got a fabulous graduation gift.
Oh yeah.
I got the
Lovely.
space shuttle Lego set.
Oh,
That's insane.
dude,
It was,
Alex.
it was built in 6 hours.
Yes.
I'm glad you could be there, Craig.
yeah, I just got back like an hour ago.
Craig, you had to do it to him.
True.
Um,
Hey, hello.
Hello.
Hi there,
Hello.
everyone.
all right. Oh, hi, Bill.
Hello, how are you today?
I'm good. I'm Craig. I've been the one corresponding with you over email.
Sure, great. Nice to meet you, Craig.
Yeah. All right. Let's give it a minute to see if a few more people are going to join us. I'm the one in person showing off the rocket.
Okay. Are you all finished with the semester?
Yeah.
Yep.
Okay.
Ended out.
Congratulations. I know that can be stressful.
Yeah. Yeah. I just graduated on last Friday, so about a week ago now.
Fantastic. Still coming to Spaceport though.
Yeah. Yeah.
Okay.
I got my job start to push a week so I can still come to Spaceport.
Okay. Awesome. Have you all been to Spaceport before, or is this a first visit?
Craig and I have.
Okay.
Yeah. Both of us have. I believe Encore
Obviously.
is here. No, Encore isn't here. There's a
No.
few,
Good.
Okay.
but for some it will be their first. So
Okay.
yeah.
Well, those of you who've been there before, be sure to share with everyone that, just how hostile that environment is and how important it is to stay hydrated if you want to survive the week. So,
Yeah.
My brother goes to Arizona, and they were just driving from Arizona back to Colorado where I'm at, and they said that a lot of that New Mexico area was like 85, 90 degrees, but like 40 miles an hour wind where they were
Well,
going. So kind of
yeah, I'm trying to remember. We had one year, was it two, maybe 3 years ago that the Wednesday when we first got out to the launch pads, we couldn't even get in there because it was pouring rain. It was the most unbelievable.
Yeah, that was my first spaceport actually.
Oh, okay. So you were there for that because I remember the next morning, I went out to the pads before you all got there, and there were tarantulas everywhere. It was like something out of a horror movie. But I think because it had been raining so hard the day before that it maybe displaced them. But
their berms get filled with water.
is that what it is? Because I mean, it looked like something right out of a horror movie.
Yeah, that sounds awful.
Yeah.
And then our faculty advisor, Sarah Lego, said she was experiencing some technical difficulties and might be a little bit late, but she's on her way.
Fantastic.
Yeah, that's all right. She just wanted to, I think, hop in just to see what we were doing. We can handle most of the safety review.
Yep. And I think I heard when I came on that you're already recording, which is good.
Yeah, I started the cloud recording because I know that from last year we did it. We needed it to be recorded. So
I was going to say, or I've already had one where we are completely done, and like a half hour later, I get an email of we forgot to press record.
Oh,
So
man.
yeah. But it'll be okay. It's not like they would make you do it over again or anything like that. But they're uploading these, they're sharing them with other teams. It's kind of a learning experience and stuff like that too. So, but relax, have fun with this. We're not judging this. You're not gaining or losing points today. I think how this all started was a few years ago. We had teams showing up to the event who their rockets were not ready to fly. I mean, they were epoxying fins in place in the car on the way to the event and stuff like that. And we needed we needed some assurance that people were taking this seriously and were ready to go. So if you can largely show a mostly completed rocket, we don't expect everything to be just ready to go. Then it'll go along just swimmingly. So don't worry about that one bit.
Awesome.
All right. Well, we do have largely a completed rocket. Really.
All right. Well, we're done.
Yeah. I have it sitting right behind me here. I'll carry the laptop around to show.
Okay. Yep.
But yeah, I guess whenever I'll wait until 4:05. I think 5 minutes after the start time is always a good amount of time.
That's fine. Do you have access to shop areas and things? If you have anything that you have to finish between now and going to Las Cruces?
Yeah, we would certainly be able to make some modifications.
Okay.
Obviously, we wouldn't be able to rebuild an entire rocket, but
Of course not. No. Yeah.
yeah, just because of time constraint. But I'm currently in our lab space that we have. We have this corner. It's a little messy, but this big warehouse essentially off in the corner of our university's campus.
Nice.
And this is our dedicated space for the club. So yeah, we have all the tools we need to make modifications. And
For logistics, are you driving out there, or do you have just a team that's driving it and the rest are flying, or something like along that line?
it's pretty complicated for the whole team, but
Yeah.
we have one main. We're going to have basically we're renting a minivan from the university's fleet, and we're going to drive from here to Las Cruces.
That's a long drive. Yeah.
29-hour drive. I've done it only once before because last year I had to fly out and meet Davis actually in Denver and drive down.
I'm in Denver, so it's a lot easier of a drive.
Sure.
A couple people fly to me, and it just makes it easier that way. And
Okay.
I think,
Yeah, I think that story plays out a lot, right? You have some people who are on internships, people who've started their jobs and everything else, and they all get together, get there one way or another. But
But yeah, the rocket will be transported in the car, so that's how we'll get all that stuff there.
is your motor meeting you there, or are you transporting your motor?
We have it currently. It's still in the shipping container. We haven't
Okay.
unlocked anything from
Sure.
it other than we took out the instructions just to look over what equipment we might need. And actually, we're flying a Loki motor, so we're going to be doing a call with Scott before we build our motor to ensure
Fantastic.
that we build it correctly because we've never built a Loki motor. And Scott also wanted to make sure that we were following all the right steps and everything since it's a relatively new reload that he's created.
All right. Does the Loki motor require bonding?
Yeah, it will require grain bonding.
Yep. Yeah. And
I'm sure
that
we will.
depending, I don't know what glue he requires you to use for that, but for some, especially if it's some type of epoxy, the clock's ticking and you gotta get moving.
Yeah.
So yeah, we have some wonderful bonding stories here about glue setting when we wish it wouldn't and things like that. So
yeah, we had to build a moon burner, well, actually both years, but our first year was a Cesaroni 6GXL moon burner, so that was quite a time to bond that all together.
yeah, well, everything has to be lined up perfectly on that one, right? Yeah,
that one's the challenge is because the grains they have an order obviously, and they also have to be lined up with the offset people. So yeah, that was it. All right. Would you like to get started with the overview of the rocket?
well, let's do it. Yeah.
Yeah. All right. I guess we can start with some introduction. So I'm Craig. I'm the project manager / chief engineer for this the Spaceport project. I've been leading this aspect of the club since end of my sophomore year. So this will be my third year going to Spaceport. Really, it's my second year leading the whole team though. And then I guess we can start with Ben, who is our president.
Sure. So as you've heard, my name is Ben Stout. I'm the president of our organization here. I've been the president. This will be my second term now. I started out as vice president, and I'm going into my junior year at Penn State as a major in security and risk analysis. So I'm actually nothing aerospace related. But I'll tell you what, this club has taught me a whole lot, and I'm super excited to go to Spaceport. This will be my first time going to Spaceport, and I'm sure I'll be learning a lot more here in this meeting here. So looking forward to it. And I'll pass it to Davis.
All right, I'm Davis. I just graduated as an aerospace engineer.
Congratulations.
Thank you. This will be my second spaceport. I am the former structures lead. So I worked along with Craig, less on the design aspect, more on leading the team on the manufacturing aspect. So we're, kind of running the lab, getting the assembly processes put together, working on the airframe entirely. So that was my duties.
Great.
I don't know, Alex, you want to talk?
All right, so my name is Alex. I'm going into my sophomore year. I'm the current vice president, and then I'll be moving to take Craig's job as the solids project manager and chief engineer. This will be my first time going to spaceport.
And who do you pass it to?
I pass it to Joe.
Hi, I'm Joe. I'm one of the technical advisors for the club. I guess I'm for your guys' parlay. It's the flyer of record. So I work with rockets and propulsion professionally, and then I'm TRA 12413. So that's all I gotta say about that.
Fantastic. All right.
Let's go, Elizabeth.
Hi, I don't know if my mic is working.
It's working. We can hear you. Yep.
I'm Elizabeth. I'm going into my sophomore year for aerospace engineering. This year, freshman year, I worked as just a helper for solids, and I'll be next semester the payload lead for the rocket.
Okay. So you're finishing your freshman year?
I just did. So
Just did, yeah. Okay.
So I'm in a sophomore year.
Okay. I have an anecdote for you that you'll like. One time I was at Spaceport and a young lady just like you, after her freshman year, went to Spaceport, and she said to me, she goes, a year ago I needed a pass to go to the, in the hallway,
Yeah.
and now I'm launching rockets. It was both the most inspirational and terrifying thing I had ever heard. So
It's exciting. It is very exciting. I'm very happy to go to Spaceport for the first time.
all right.
And Encore.
Hey, my name's Encore. I'm the liquids project manager for the club. I help around with SOD sometimes. And I'm a rising senior.
All right.
That's pretty cool.
I didn't know Penn had a liquids program. Do you have a venue where you can static test?
We do. We're planning on test firing at I think it's the track
Yeah,
close
the test
by.
track.
Mhm.
We used to have a Lunar X Prize team, which then turned into a liquid propulsion development team, and then we merged clubs. So a bunch of complicated stuff, but we've basically been grandfathered into
Sure.
they have a test track facility where our formula team will test their race car,
okay.
and then off into the side, there's a big old impact pendulum where they let us just set up our test stand, and we can stand the proper distance away and then test it.
Well, the only reason I ask is that so many universities struggle getting liquids programming going, and almost always is because they have no physical place that they can safely test the engine. So I just ask how people do it and where they do it, just so I can get more information to share it with other schools. So thank you very much for that.
Yeah. Well, I think specifically Penn State already does propulsion testing. Through nuclear engineering actually. But then the specific test area they're talking about actually is already rated for sound, noise, and airspace restrictions. So that's how their student clubs can test out there because it's already a controlled area anyways.
Okay. All right.
All right. Shall we get started with the actual rocket?
Yeah, let's do it.
We shall.
All right, so I'll be trying to take it apart by myself, which might be a little challenging. It's just everyone else had to leave. I had to drive back up here earlier.
I want
Say?
that thing to that nose cone's heavy.
Didn't I
This
ask
goes
if,
not heavy because we took the payload out.
I asked if you wanted us to meet you over there.
Yeah, it's fine. I'm just gonna
Alex
shift it.
can tell you, when I showed her the lab, she would not stop talking about how the rocket is top heavy after seeing it for the first time.
Well, it helps with stability. So
I was
Okay.
going to say, yeah, everyone's putting wait in the nose cone, so you don't have to.
So this is where we're going to have our payload. It's a commercial nose cone. We bought it from Wildman, 6-inch diameter. The coupler was custom made, so I don't know if you can see that. It's a fiberglass coupler here. We have 2 all threads, and actually, if you look inside, you can see our cube mount. So it's a 4U cube set, actually. I don't know, maybe if I hold my flashlight, you'll be able to see the top, but we have a little blocker at the top, so you basically slide it in. Yeah, you can see there's an upper mount and then a beam going across. So we can slide a 4U CubeSat in, and then we have another disc.
There's a G10 disc that goes, and it basically sandwiches it between that upper mount and the lower mount.
I'll be right back.
And basically, the way that coupler itself is actually epoxied directly to the nose cone, and then everything is bolted into the square cut bulkheads. So we have 2 square cut bulkheads. Everything's bolted into that.
Okay, I have all the parts for it. So this is our our makeshift math simulator right here, which we intend to fly on our test flight. So this weighs exactly 4. Sorry, I'm like below the frame. This weighs exactly 4 kilograms. We poured out epoxy with some ballast weight into 3D printed blocks, basically, to get the form, and then it's held together with an all thread. So basically, you compress it together. It has the right mass. So it's actually, this is quite dense. But it slides into the nose cone. Loosely. Just a big thing to hold.
Probably not designed for one guy to demonstrate,
No,
huh? So
not perfect for one person, but it's definitely, I'd say this is the nicest payload mount we've ever made.
I don't know. The square last year was kind of fun.
Yeah, but installing it is not as fun.
True.
That's why it was just always installed.
Bunker, how many times do you unpack that payload?
I think at least like 3 times, multiple times in a day.
All right, it's a little hard for me to slide this all the way in to do it, but I can show you how. We had 2 people. Once it's in, it's just a little heavy for me to do one-handed. Once it's in, we'd have this disc right here, and it lines up with the all thread, which are connected to a disc. We thought about the load pathing on this, so it's actually connected to a disc, another G10 disc at the top here, that sits on top of the lip of this coupler. So the entire load of the payload is compressed between this coupler. So it's all going through this fiberglass coupler we have here. And then the fiberglass coupler itself is epoxied in. So yeah, that would go in there. We have nuts and washers to press it in, and that way it gets a nice tight fit. And then to interface with the actual recovery system, because this is also our main deployment, right above our main deployment charge and parachute. Jackknives. All right. Basically, this goes on. It's got a little lift, like a stepped av bay here, and we've got a forged eye bolt we picked up from McMaster, rated to, I believe it's 1,300 pounds for the 3/8 ones, which should be more than enough for a nominal flight.
That eye bolt is rated to far beyond what we would expect.
Oh, yeah.
Yeah, they're hefty. Oh my God, I don't know why I can't. I guess
Need
that's
me to drive up?
one-handed. Yeah, drive up here and help me.
Yeah, I can meet you there, Craig. Just give me 25 hours.
Try rotating. Yeah.
It's okay, Craig.
All right. Sorry I'm getting so caught up on it. But yeah, that's our payload now. So any questions about that or?
no, that's fine. I can imagine that finished.
Yeah.
Yep.
Yeah, because we were prepared to do a test flight, like I said, and then we ran into some issues with the avionics. So I guess I'll pop our main parachute tube off. which is also a fiberglass tube. So the entire upper half is fiberglass, which we did for the radio transparency for our GPS units. So this is painted fiberglass, but you can see the inside. You can tell it's custom made. We made it on our aluminum 6-inch mandrel. Just wet layup with fiberglass sleeves. Same way we did our carbon fiber tubes, but with fiberglass.
I'm just curious, any trouble demolding that?
Oh yeah, tons.
Okay.
Plenty.
Okay.
That's been our biggest issue.
Well,
We did find some thick mylar that has worked well, but the issue is sometimes it will put massive wrinkles in it. If you don't get it taut enough. So we have not come up with a perfect way to make these tubes, but we've come up with a way to make these tubes.
I'll try to remember if I can get you a video of what we've done here at Iowa State. We have this big metal cage, if you can imagine it, that the mandrel and everything goes into, and then you just use a pneumatic wrench to turn a screw, and it slowly pushes the finished piece out of the mandrel, or pushes the mandrel out of the finished piece.
That'd be really nice.
That's cool.
Yeah, we've come up with so many different ideas for how to push them off, but like, yeah, we really just need to make some type of mechanical pulling mechanism to get them off. Because honestly, the mold, we have like mold release wax and these agents and stuff. It's so hard to apply the right amount of force to get them off.
Yep.
Another issue that we ran into, because I did a lot of the demolding, I just come in and try to demold them, is the body tubes themselves were often just, to make the composite with extra to be cut off would be the length of the mandrel, because our mandrel is not terribly long. So often we wouldn't have any purchase on the aluminum outside the composite. So finding a place where we could grab it, get some kind of mechanical advantage on the mandrel is kind of difficult too.
Yeah, it's hard to put a nice controlled force on it, and that's why I say that having a screw and on an impact wrench, so it's jiggling it a little bit as it goes too, so it works out really nice. So.
All right, so the next part right here is our avionics bay, which is also custom made. So we have the lower bulkhead is bolted in, and I know it probably looks like wood. This is actually glassed plywood. So what we did is we put a few layers of fiberglass over top of this so that it would be able to take the load and have that layer of protection on top of it. And then the wood gave it some stiffness, or thickness, so that we'd have actual stiffness in the plate.
Right, and a surface to glue against and stuff like that. It's I don't have any problem with woods. Yeah, so
yeah. It's a great, it was a great material, also easy to purchase, and we made it using a vacuum bag on a table. We just vacuum bagged it straight to a table, and that's how we got a nice flat, smooth finish on it. So yeah, eye bolt here, we got screw terminals. We have redundant screw terminals because I think the person installing them thought we were doing redundant charges within our charges, and we were like, all right, that's a little carried away. But doesn't hurt. We have plenty of space on here, which is really great in a 6-inch airframe. And then
that lower bulkhead is epoxied on, so that lower bulkhead does not come off.
Yeah, we actually have, if you look through, you can kind of see down. We actually have a load spreader of G10 at the bottom there for just the all threads as well. As well as a really, really wide washer for the main eye bolt. Just so that recovery loading goes through the right load path there. And then you can kind of see, I'm not sure if you can tell, but it's a JB Weld epoxy fillet down at the bottom there.
Right.
And then for the actual sled, grab that. That won't roll away. So this is our avionics sled, which only takes up half of the space inside the av bay. So one of the things we were considering doing is punching a small hole in the side and putting a camera system below this. So this disc basically separates everything out. We weren't sure if the competition rules would have a problem with having something payload related in the same compartment as the avionics, but they wouldn't be electronically connected at all.
I don't think they're going to object to that.
Yeah,
So,
we just
yeah.
wanted a horizon connector. We thought
Yep.
it'd be
Yep.
But anyway, so the actual flight electronics, the way they work was we have Molex connectors straight out of, not from a computer, but the same that you'd find for electrical components within a computer. They work really well. They're a very durable connector, and they're hooked up to the wires that are all, they're currently not connected to their strain relief. I'm not sure if I can hold it there properly, but we have little brackets here to pinch these wires in here with a mechanical fastener. And that way, if you pull on this, it's not pulling directly on any of the
Right.
screw terminals
Right. Yep.
that you can see in there. So that's really good strain relief, and it just makes it so that while you're taking it apart and everything, you're not going to damage the actual electronic components. While I'm talking about the electronics, you might have noticed what we have here, but it's a Stratologger CF as our backup, and a Telemetrum, I think it's version 4, is our um, all right, yeah.
Yeah.
It's this is our first year using a Telemetrum, actually. We've been using Stratologgers for ages. We have just a backlog, I guess, not as many as we would like anymore. We sadly lost 2 in our flight last year. But we still have a few more laying around that we're able to pull from. They're great flight computers. They just kind of work. So, and then obviously the Telemetrum, we've heard great things about it, and it also has GPS, which is
Right. Yeah, integrated. Yep.
And then I guess I'll rotate around to the side here to show you the switch. So we were using barrel switches before, which are little screw switches. We've flown them before at Spaceport twice, and they've worked well enough. Haven't really run into issues. But as I've been testing them and using them, I've used one for my personal rocket, and also we were using them in our flight electronics on our test day. We found that they tend to fail in torsion after a certain amount of on-off cycles. So we switched to a switch that is rated for a lot more cycles. It is side to side, but the hole is big enough that you can just take any stick in there and slide it to the side and turn it on. It's fairly simple. That one's hooked up to Telemetrum, and then the classic Stratologger.
So that those switches, I mean, can you feel a click, or I mean,
Yes.
I'm just okay.
Yeah, here
yeah.
I can try and hold it closer to the mic,
Okay.
but you can kind of hear they click.
I'll believe you on that. I
Yeah.
just that I don't object to it in any way. It's not something I've seen before, but
Yeah. It's not something we've tried before in a flight vehicle, but we had concerns with the barrel switches, which is
Oh yeah, and there's a lot of anecdotal information out there of those barrel switches failing. I personally have, I use screw switches on everything. But,
yeah, I was actually we've never used those either. I bought a few of those from I can't remember. I think it was Additive Manufacturing or something like that.
Okay.
Additive Aerospace, I think is the name. I bought a few of those, and I'm going to try. They're little PCB screw switches. I'm going to try those out. And I'll let the club know if I like those.
Yeah, if you do and you mentioned additive, I think they do it is so long as you have something that captures the screw so that you can't spin it out and listen to it fall down inside your rocket. So
yeah. Yeah, they have some type of backing on it, but I'll have to look more into that.
Sure.
These switches we purchased straight off of DigiKey.
Yeah, and they're perpendicular to the big push. So
we mounted.
They're rated for 50G shock in every direction, though.
Okay, all right. So yeah, but still, I mean, good design. Yeah.
Yep. And then we basically just had this base plate here as kind of a separator, and there's a wire pass-through for the charges on the bottom, and they're also hooked up to a Molex, and those also have a strain relief section right here. We have a little section to basically screw in a little bar across here and pinch them down so that they're not pulling directly on the screw terminals.
Very good.
And then for the back side, we decided to put a redundant GPS in because we've had a GPS failure before. with the big red B, basically just giving us stale coordinates. So in the unlikely event that one of our GPSs fail, hopefully one of them is still working. And we had a featherweight, so we threw that in the back here with a pretty large single cell LiPo. We made sure that it was following the competition rules, but I believe this is a 2600 milliamp hour battery.
Okay.
So it will last forever. Yeah. Any questions about the electronic setup?
No, I like that the wiring is all really simple and intuitive. I mean, when you do the safety review, they're gonna look at that, and it's nice to just it all looks nice and neat and logical. So good job.
Yeah, thank you. All right, let me put that down. I'll move on. Oh, I guess I can show you the top of the av bay. So this is our top lid. It's basically the same setup here, but you can see there's marks for where the washers are because we've ejection tested it a few times. And then we have another Molex connector coming down, so that way we can easily interface with the charges. And then we have another load spreader here, and then we have this 3D printed ring with a O-ring to try and improve the sealing between the two. To make sure that we don't get any of those ejection gases going into the avionics bay and destroying the barometric sensors.
You have to forgive me because I have to review a lot of different rockets. Just remind me what size your powder charges are.
Yeah, so on the I think both of them are similar sizes. What did we finally go with? 3 grams and 4?
We had
I believe
instructions at 2.8, and we're probably going to do 3 and then 4 for the redundant.
Okay.
As we discussed.
Yeah, because both of our ejection chambers are very similar in size. I think there's like a 2-inch difference between the lengths of them, and they're the same diameter.
Okay.
So we basically just went, all right, make them a little bigger, give them a little bit more oomph than what we calculated. And hopefully that should work. We wrap them very tightly to keep them compact, so hopefully all the black powder burns. So far we've on the one flight that we have flown to 30, it was actually 36,000 feet. The way we did the charges is the same way, and they at least deployed and separated the rocket because we did get it back. Just our GPS failed, so it was many weeks later when somebody else found it.
And we've had successful ejection charges on both the drogue end and the main end. So
yeah, for this rocket.
Yeah, for this rocket. So I think we're happy with our sizes.
Yeah, I think we'll probably do one more test of our sizes and everything after we've finished everything, because I know I've sanded the inside a little bit, so I want to make sure that sealing surface is good, because we've dripped epoxy accidentally inside there. But yeah, so far it's working as intended.
Okay, not telling you what to do, but when you're integrating your rocket out at Spaceport, just because it's such a dusty environment, I like to take like those I think Goop or Gojo, one of those companies, make like a pre-wetted shop towel and wipe down those surfaces and then dry them all up. So, because if you have dust that's accumulating, imagine like 1,000 little door wedges, between the coupler and the inside of the rocket. So just really nice to have that really super clean.
Yeah, definitely make it easier to get those surfaces mated together. Right. So I'll move down the road there. So this is the first carbon fiber section. So this will be our drogue parachute. Where that will come out of. This one's a little harder to do by myself. I think I can do it myself. It's a very light rocket for how big it is.
To iterate,
is 33 pounds, I think, about.
Wow.
To iterate though, also just while we were talking about the avionics coupler, both body tubes connected to that avionics coupler are stationary, so it actually ejects.
Oh,
so,
yeah.
So those are pinned permanently, and then the shear pins are on the outer ends of those body tubes.
Yeah, so that was a design choice I made because I wanted both sections to push.
Yep. I appreciate that. That's a good idea. Yeah.
Yeah, I didn't want to create any pockets where it's potentially going to push the parachute in and deploy late or not at all.
Yeah,
So
you're not
both sections
just
are
separating it. You're pushing out the laundry.
Yep.
So yep.
Yeah. So this is our it's just a tube. It takes the drogue parachute and it couples. It has pins right here, holes for pins right there. We got 3 of them around. And then the actual separation surface, it will fly off and be connected to the av bay during the separation. Same way with the nose cone will pop off for the main to actually deploy. So it pushes that out and everything comes out. So here's the interesting part. Here, Davis, you can go ahead.
The bodies are actually pinned using automotive pins, and then we've got the nylon. What are they? 632 or 440 screws for the.
They're 440s, yeah.
Yeah, I use those automotive pins too. They're quick and easy.
I go to auto
really well.
AutoZone drives me nuts though, because they go and they have the ones I want, but they only have one pack for like 3 of them. And I need like 8 of these.
Yes, so I did find packs of those online for significantly cheaper, but it's one more thing to order in advance.
Yeah.
Yeah, well, if we plan for it, at least we'll be able to get it. All right, so now for the booster section, this is where the motor, so this is essentially the length of our motor.
Wow.
That's all this is. It's a 6GXL Cicerone casing. So I guess I can start by showing you the top. This coupler right here is epoxied in. It's 9 inches sticking out so that it meets the 1.5 inch or the 1.5 caliber rule, and also helps at going Mach 2. It's a custom made carbon fiber, just wrapped around here, just a standard 2x2 twill. And then the tube itself, as you can see, it's been sanded, still needs to be coated. I think, yes, right here is the first rail button mount. So we actually have I don't know if you can see on the camera, it's very small.
I can see the hole. Yeah.
We can see the hole.
Yep.
Yeah, so there's actually an aluminum threaded backing plate in there that's curved to fit it has a curved surface that curves around to fit a 6-inch diameter tube. So it's mounted up against that and epoxied in, and then
Here, Craig. I have we can't show the inner workings. I have a photo of the inside before we put the actual body tube on. Do you want me to share that?
Yeah, if you want to, I don't know, Bill, are you interested in seeing that, or you just want to see?
Sure. I love rockets. So
Can you disable screen sharing real quick?
Yeah.
Because basically we've got a little bit of an internal design that you can't see because the body tube's fully epoxied. But I've got a photo of it before we put our 6-inch on.
All right, you should be allowed to.
Yeah, I got it. All right, so it's this guy here. So basically, so this is before we put our tail cone and.
Okay, I'm still seeing a thing that says okay. Now it's sharing. Okay, got it.
Oh, did it? There. You see it?
Yep.
All right, so basically this construction is the motor tube itself. So it's the so it's the inner.
It's right down here, so you can see the fins are in the same spot. We just have a body tube over top of it.
Yep.
But the way we built this tube was with a basically load distributor that would transfer instead of having just a standard bulkhead. To
Davis, you have a bar going across.
Yeah.
Right where the transition is.
Oh, you know what that might be? I know what that is. That's the actual Zoom thing, isn't it? Did that help?
There it
There
goes.
you go.
Yeah.
Yeah, it was the actual Zoom meeting bar.
Sure.
Yeah, so we've got this load distribution thing where it transitions internally from our motor tube diameter to the inner wall of our body tube. That was just to kind of transfer some of that force instead of around through because we've got a tail cone. Instead of transferring all that force through the tail cone, we're actually transferring it through our motor tube and then into our full 6-inch body frame. You just can't see it with the body tube on because that's fully epoxied in there. We also filled this cavity, so we're from this transition down, we actually filled it with a 2-part urethane foam to just provide some internal stiffness for our tail cone, which was this guy. So this volume here is filled with a urethane foam because the tail cone itself is not the stiffest. It's mostly there aerodynamically. So we just reinforce that against the motor tube and the body tube.
Nice.
Yeah, and you can see here's the finished version of it. We put the exterior fillets on here. I'm not sure how well you can see it because I have put this up kind of high, but yeah.
Can imagine.
And then I guess we could also talk about the fin construction. They're a very interesting part of this rocket. We got these fins down to a very lightweight by using a foam core construction technique. So it's actually, I think it's very interesting how we did the analysis to prove that they would not suffer aeroelastic failure. So I don't know if are you familiar with sandwich panel construction techniques?
Oh, yeah, yep. We have composite labs, and so
okay,
yeah.
Yeah. So we used a Divicel H45 foam. It's a closed cell foam used for composite sandwich cores in aerospace and other applications as a core material. And then we laminated 2x2 twill carbon fiber 3K fabric on each end. And we did change the orientation so it has quasi-isotropic properties to try and get it as close to the way a program like FinSim would model these fins.
Yeah, we made sure to include a 40, it's the 2x2 twill, so there's 45 minus 45, but we made sure to, as well as the 090s, include one of those in there to add additional stiffness in the flutter direction. Because that was something you're flutter.
Sure. Yeah.
Yeah, actually, primarily it's divergence that we run. Yeah, so the concern was getting them stiff enough to handle Mach 2 flight, probably about 6,000 feet up, or not 6,000 feet up, 6,000 feet above sea level, so only about 2,000 feet above the launch site, maybe 3,000. So that's very, very fast. Our motor burns in about 4 seconds, so we'll I think it's 26 Gs or something off the pad as our max acceleration. Very fast. So that was our big concern, was getting something very lightweight that would also have that stiffness. And by using that foam core and moving the composites out to the edge there, we were able to get essentially, I calculated equivalent stiffnesses based on different material properties within FinSim. So I used like G10, steel, and aluminum. And I would use that to figure out, all right, I want this divergence velocity. How thick does it need to be? I'd calculate how stiff that would be if we had a monolithic, just like what the thickness is, what is the I value of that secondary moment of inertia, and then use the material properties to get an equivalent stiffness of the fins. And from there, I was able to prove that as long as the EI value of the fin, the E times I, was all the same, their flutter and divergence velocities would be roughly the same. So that's how we were able to come to the conclusion that they needed to be 1/4 inch thick with about they're in total they're 0.291, I believe, inches thick. That's the exact like caliper measurement. But that's 1/4 inch foam with 3K plies on each end.
Wow. Substantial.
Yeah, and then also the leading edge is cast epoxy using a 3D print. So I can actually show you how we got these pretty sharp. Not the sharpest. They're not like metal where they're going to cut you, but this is cast epoxy for the leading edge there.
Nice. I'll have to ask the guys here at Iowa State to go look at your rocket on Tuesday, because we like using metal edges that are sharp.
Yeah, that would technically get better performance, but the weight of metal edges actually would have doubled the weight of our fin.
Right, and they're also dangerous. So for the advantage that you get, I think that the risks are greater.
Yeah, you get pretty diminishing returns as you go sharper and sharper. Like they're already very pointy. Like as I feel them, I feel like they're kind of sharp. They could scrape something, but it's not sharp enough where I'm going to cut my finger on it if I rub it down. So yeah, they were just. Yeah, what was that, Davis?
The trouble we ran into with doing a poured tip though is getting the viscosity right.
Yeah.
Otherwise, everything kind of just runs out of your mold. So I think for that, because that's West Systems that we use, like a West Systems 105. I think by volume, it's 50% by volume micro balloons, just to give it the proper thickness. And even that was still too thin. We'd get a lot of pour out. So there was a lot of filling to have to do with them, but we were pretty happy with the way those turned out.
Yeah. Yeah, some of them turned out better than others, but it's one of those processes that as you do it, you learn how to do it better. But we're pretty happy with how they've turned out because we've gotten that essentially almost like a diamond airfoil.
Yeah. Well, like I say, I'll point some people your way to ask you some questions about that because we keep tacking aluminum on there. So
thing we also had to make sure we did, because we made a couple before we actually tacked the ones onto the rocket. A big concern of ours was actually separating the epoxy from the carbon. So what we found was we scraped out about a 1/4 inch of the foam on the edges, and we made sure, because that carbon epoxy bond was what we were getting the strongest bond from. So we had to make sure we scored out a bunch of that foam and then filled that void with epoxy, which led to some issues with getting air bubbles. But
yeah, definitely could have had some improved manufacturing processes, but I think they ended up coming out well. We had a test piece that we dropped a few times to see how it would handle just impact, and make sure that it wouldn't just chip immediately. So that is one concern, is that the leading edges may chip on recovery, but the good news is because they're just cast epoxy, it's pretty simple to repair. Like it's not a huge issue, but that would be something we'd want to look into in the future. But the one we tested worked fine on concrete, so we'll see how it actually fares out in the desert, because that's a pretty hard surface to land on.
The desert's a lot like concrete.
Yeah.
So
yeah, our East Coast launch sites are very soft. I was able to recover one of my rockets under just a drogue, and it hit the ground going about 60 feet a second, and it was essentially fine except for one of the fillets cracked, so I had to repair that. But the mud really saved it. All right. I guess the last part to talk about is just the very back. So the tail cone, you can see, goes down to the motor tube right here, and it goes straight. The motor actually comes up so that it's about an inch beneath where the surface of this coupler is. And we have an upper centering feature. It's a pretty hefty ABS 3D printed part with a large chamfer, so that as the motor slides in, because the motor tube isn't full length, so as the motor gets close to the top, it's a second point of contact.
directs it. Yeah.
Directed. And we had issues in the past where we weren't able to guide it in.
So are you using the forward closure for your retainer then? Is that
yes,
you're just okay?
Yeah, it's going to be a head-end retention. The motor tube's up there. I believe I'm looking around for the actual bulkhead we're going to use. We have some eye bolts that are slightly longer so that you can get that retention done through the head to screw in and hold it in place. And I'm not sure. This lab is kind of messy. We need to clean this.
the tail cone that was on there was kind of a new thing for us, though. We'd never really done kind of what I would consider that a more complex geometry. It was done over a 3D printed mandrel, and we just took the same biaxial sleeves, and we did a first attempt where we just let it drape. We ran into some surface issues and some consolidation of the actual composite. So the second attempt, we actually made an envelope bag and pulled the vacuum on it, and we turned out with a fantastic part. And then we just manually slotted it. There's a second part that goes with it. It's kind of a cone that tapers into a coupler that's bonded in. We bond that together, and then we slotted them together when we put the fins on, or fit the cone to the fins.
Nice.
It was Alex, how long did I spend slotting that cone? 3 hours? 4 hours? That was just a cone.
Yeah, I remember a lot more than that.
Well, because both the body tube and the cone are slotted. So we had to slot from both ends and make sure they all fit together, as well as getting the coupler to still slide under the main body tube.
Yeah, it was a lot of time spent putting it on about 90% of the way and then finding out, well, this is where it sort of catches or bends in a way we don't like. So then we mark it, take it off, tack off some material and try again.
Not sure what you guys were talking about, but I did find the actual bulkhead. It's the same as the ones we used on the Av Bay. It's cut from the same plate actually. So it's actually two different sized bulkheads glued together so that we have a little bit of a lip here. It makes it easier to center, basically.
You bet. Yep.
And then we actually have it configured for our test launch setup, which uses an all thread that we cut to length, and then an eye nut with a lock nut on top to keep that locked in. And then it's sandwiched in here. So that way we can basically pop it on top of here. It will retain the 75 millimeter motor.
It's a bit of an eyeball job because you got to blindly screw in that all thread like 3 feet down.
Well, it's not the worst because it will sit here, you'll put it in, and then you move it around, and eventually it finds the chamfer, and then you can screw it in. But yeah, so it's head end retention for the for both sets of motors. We did think about making the tail cone a little wider at the base and then having a rear retention. But the narrowing it down gave us that extra bit of altitude, and we're already barely making it to altitude as is. So yeah.
They both work as long as the motor stays with your booster. That's success. So you'll be fine. I have seen on occasion where you struggle a little bit to remove the motor after the burn. It looks like there's other ways you could take that apart if you had to. You could spin that. Yeah. Yep.
We'll have access to the whole top of it.
Right.
Yep. Down to the top.
Yep.
To get it out.
Yeah, you could take that whole bulkhead if you had to off and just bring the whole thing back. So.
Yeah, we thought about epoxying this bulkhead in for better sealing, but we found through ejection testing that it really doesn't seem to leak much at all.
Sure.
So having the ability to remove this bulkhead definitely makes ease of flying it a lot better. I saw this sitting around. This was our test fin actually, so you can see it was cut to the profile without the leading edges, and you can see we chipped it off in sections just to see how it would fracture. This was also using a JB weld instead of the West Systems, and the JB weld is significantly denser, so it actually weighed more. But you can see the foam that we scored out here. Actually, The bottom shows you a more solid, so you can kind of see that it's just very lightweight foam in the middle, and then very, very stiff composite that you really does not budge.
Sure. Good.
So yeah, we'll probably bring this to our poster session also to show the construction method that we used for the fins, because they're pretty great. Because lighter fins are just better all around. You get your stability goes up and mass goes down.
Mm-hmm.
So yeah, I think that's the whole rocket for right now. I can pull our motor casing out, but it's a standard Cesaroni 6GXL if you've ever seen their hardware.
I've got 6 of them, so yeah. So we use a lot. Well, not anymore because we can't get propellant right now. But we used to use a lot of the 3400s because we do payloads for the Department of Energy, and that's sort of the standard. I think so far we've done 11 of the 3400s and consistent good motor. So yeah, I'm very, very familiar with that casing. So
yeah, we would have loved to fly the 3400, but yeah, we couldn't really select any Cesaroni motors.
No.
We got stuck. We were gonna fly a Cesaroni motor last year, and then we got stuck because they didn't. So we had to switch to a much lower performance motor and change around our rocket design quite a bit.
We ordered 4 03400s in December of 22, and I just heard that we will receive them in May here, but I won't believe it until they're sitting here.
Yeah.
So yeah, right now I think it's just a unicorn. So
Did you post about it online? I thought I saw
Yeah.
somebody writing
Yep.
about. Yeah. Okay.
yeah, I was like, is this, am I dreaming or what? But they say they're coming. So
Yeah.
yeah, but again, I'll believe it when I see it. So
3-year lead time's not bad.
yeah, how about that? So and if you know anything about grants and stuff, you know that there's very specific times when you have to receive the money, spend the money, and things like that. And I think I have like $12,000 wrapped around propellant, and we don't know how to pay for it. So
So you know
yeah.
who's going to glare at you when you ask for a no cost extension? They're just
Yep. We'll just say, talk to our neighbors to the north. So
yeah.
One comment, Craig. I think I heard you mention the required 1.5 caliber for the shoulders on your couplers.
Yeah.
That was a long time ago. It's only 1 caliber, and so make sure that you're looking at the latest, greatest version of the DTEG.
When was that changed?
Oh man, quite some time ago, because there's a lot of pushback. In fact, there was pushback from people like me, people who are on the other side of this, saying, man, that's a really, long coupler. So yeah.
We also thought that.
Yep.
It's like, it doesn't make sense. That's so long of a coupler.
Right.
Yeah.
And for me, it's a safety thing, because, what I'm looking at right now is version. Well, I bet there's a newer one than this, but I'm pretty sure I have an open one right now. Let me go to the web page. Let me see what they got there.
Yeah, because I remember I checked it back in December, I think.
Okay.
And we kind of finalized our design and started construction of the rocket. So I will admit I haven't checked it. If it was changed in the last like 3 months, then I would not have seen that change. I do remember being a little annoyed with that.
Yeah.
When I got my design, I saw the 1.5 and I was like, all right, well. So we designed our coupler to only have 1 caliper because it was fixed in place, and then we made every separation point 1.5.
Yeah, I want to say, all the separation points are 1, and then on the nose cone 1/2.
Yeah.
Yeah. So
Well, that would have made this a little bit easier, but we already have it built. We're overkill, I guess.
yeah, I'll send you an. I can't talk and type. But I'll look that up and send it to you. So yeah.
Okay.
Yeah.
I can also check the main sounding rocketry.
Yep.
I normally will download them from the site a little bit after the initial proposal, and then I'll check on HeroX a few times just to see if there's updates. But yeah, I normally follow what's given out around the time of when the initial proposal is made, unless a HeroX update comes out.
Okay. All right. Well, I mean, having done safety reviews on lots of spaceport rockets, you've done nice, neat work, and anything that's worth doing is worth doing well, and so I appreciate the amount of time and effort that you're putting into it for it should look good on the inside, even though it's all going to be buttoned up. It's unfinished. Are you gonna fly it naked? Are you gonna paint the rocket decal? How are you finishing it?
Yeah, so we're planning to do so I guess the paint scheme here is pink on the fiberglass, and then for the carbon, so it's a little matte right now. We're planning to just spray clear coat on the side once it's sanded down.
The carbon looks good, so we might as well clear coat it and show it off.
Sure.
Yeah. And then the leading edges of things we were also going to paint pink, make them look a little better, because currently there's a mix between the color of the epoxy and some Bondo color to fill in some micro voids.
Right. Well, just again, not telling you what to do, but just kind of going with, what I'm hearing. I think that they're going to have the main bank where the solids are. You remember how it used to be cell A over here in BC? I think it's all going to be together. So you're going to have something like 24 pads all together, which means that a rocket could sit out there for a really long time. And if it's a sunny day like we hope it is, you're going to have a lot of sun beaten down on it. So that's just something to consider as far as color choices and things like that, because it could get hot, and I don't know if that affects what's inside your rocket, be it your experiment or anything else like that. It's just saying. So
Yeah, we've had a rocket sit out on the pad for 7 hours before it launched. So
okay, all right.
Oh
So,
yeah, flying 30K. What is it? Was it 2020? That was a rough year.
22, I think.
22. Okay.
Yeah.
But yeah, we got robbed.
Yeah.
we let that rocket heat soak as much as you can. It did it like we sat it out there for about 2 days of cooking.
okay.
Waiting for the clearance to go to 30K while I guess that would be my objection to them doing the combined pads though, is that you do have low cloud ceilings sometimes where you want to turn and burn the 10Ks because they're easy.
Right. Well, it's there's a lot of people involved in this. You've got Ezra, you've got Spaceport, you've got Tripoli, and so you have a lot of people that you got to get to agree on something. So but yeah, I remember exactly what you're talking about, that we were all sitting there waiting to launch rockets and so on. But anyhow, just if we do have a nice sunny day, they're going to be baking out there, even if it's going smoothly, right? Someone has to be pad 24 or whatever it is, so just kind of anticipate that. But no, looks great. You're doing really good work, I'm very confident that you're going to bring a finished rocket to the safety review. So I know it sounds absurd, okay, but it has happened where they were doing the final safety check, and we're like, why don't you go back and finish your rocket, and then we'll do the review. So anyhow, I already mentioned you have probably half of the team has already been there. Make sure you share with the people who are being there the first time what to expect, how to stay alive, things like that. And I guess if you have any, I can try. If you have any particular questions or comments, I can get that to the board. But otherwise, fantastic. See you in June.
Yeah.
Thank you very much.
Yeah.
I don't have
I was going to say, look for the guy in a blue shirt with a bald head, but that's pretty much everybody in Ezra. So, so yeah. Okay.
All right.
Well, thank you very much.
You're very welcome. Upload your video. Thanks.
Yeah. Do you just want us to send you the video like an email?
It doesn't go to me. I think there's instructions in Hero X.
Oh, okay. I'll check that then.
Yeah.
Because the recording should save to the cloud as soon as we're done.
Okay.
And then once it processes, you should be able to watch it.
Yeah. Good work. Congratulations. And for those of you, and see you in June.
Yeah. I look forward to it.
All right. Bye-bye.
All right. See you.
Thank you.